The process was majorly inspired by the financial constraints I was running into. I needed it to be cheaper. To give you a perspective, so in 2020, a snapshot would be 112 megabytes, and that meant I could take quite a few snapshots each and every day. And the storage requirements back then, I estimated them to be around 10 terabytes per year. And people would sometimes donate a hard disk here and there. And we built large storage arrays using ZFS and, hosting a few terabytes of data. Yeah, it's an investment, but it was doable. But if we look at the cost of storage today and how the RPKI has grown to be roughly 500-600 megabytes per snapshot with multiple nodes, right now, the original approach of RPKI views is 50-60 terabytes per year.
You're listening to Ping, a podcast by APNIC discussing all things related to measuring the internet. I'm your host, George Michelson. This time on Ping, I'm talking to Job Snijders again about RPKI. Job has been running a data collection exercise for some time, aiming to archive the worldwide state of the RPKI repository structure for analysis. Repositories are a key concept in public key certification frameworks. Their location online is bound into the mechanism by being signed into certificates and stand as the publication point for fetching data. This is how certificate issuance and signed object processes can tell you where to look. And for RPKI, Resource PKI, it's how all the signed objects for ROAs, root origin attestations, and ASPA, the new Autonomous System Provider authorizations, are made available for everyone to download and use, validating the state of BGP. To validate BGP, you need to see all of this data. And to see all of the data, you need to go to all of the publication points worldwide. Problem is, some are unreliable, many are a long way away from you, and it's highly likely that they publish changed cryptographic objects which actually re-encode no substantive change in the assertions over BGP. So Job has been dealing with an ever-increasing and therefore slower process, which costs him time and disk space. Job and his collaborators in the IETF have been working on the design of a new way to represent the state of signed objects. This is called Canonical Cache Representation, or CCR. This has allowed Job to move from a massive future cost risk, exploding data storage and time cost, to a compact, high-speed model of the snapshot view of the global RPKI repository state. This can be maintained, spooled, collated, and analyzed far more simply. He's deliberately designed this using standard POSIX Unix tools to manage the data, so that normal techniques of data management and analysis we all use at the shell prompt can be used.
Job, welcome back to Ping. It's lovely to see you again.
Hey, George. Good to be here.
So last time we were talking about a body of work you've been doing in RPKI that's a little less about measurement, although it was informed by measured observations you were making in the ecology, and it has a measurement story we might come back to. But I know that you have had a long-term interest in the idea we need to understand the shape of the RPKI information space. And I'm intrigued by how you can build and bootstrap something to tell us about the state of RPKI. What have you been doing here?
So a number of years ago, in 2020-ish, I set up a project called RPKI Views. You can access the website on rpkiviews.org. And the idea of the project simply was, I want to capture all the RPKI data. If I capture all the RPKI data and make it accessible again in a structured fashion, like that I can just send somebody a URL like, look, this was yesterday's RPKI data, that helps us reason and discuss events in the RPKI.
So we have history here. There's this amazing investment, a repository of knowledge of states of BGP maintained at the University of Oregon. route views, and I'm looking route views, RPKI views, it resonates, right?
Yeah. I love route views. I've used it so many times throughout my career to understand what happened in a particular event, like who were the parties that were involved, what were the routers sending each other in terms of messaging. And I've used route views so many times to explain to my bosses, like, yesterday's outage.
Really become a critical resource for analytics in BGP and for research publishing in BGP. We recently spoke with Thomas Holterbach and Thomas Alfoy from Strasbourg, and they made a distinction in their service. They take feed from RIS, feed from route views, feed from BMP sources, but they've decided to offer service in a 3-month view because they feel the cost of maintenance of a lifetime history is beyond the scope for your project. But in constructing RPKI views, you're hoping to manage the data retention problem, aren't you? You want to hold history.
Yes, I want to capture everything and store it forever.
Wow, that's a big ambition.
Yeah. So I really liked the sort of simple access of route views, that they had an open directory structure and it was categorized by year, by month, by day. And then for a particular hour, you could download the data that happened in that hour. And I thought to myself, I want to access RPKI data in a similar way. And it didn't exist. Like, it was not another project that had the granularity I was looking for. So I started by running the validation process and then simply taking the cache directory that is the resulting state and wrapping that in a compressed tarball. So using standard,
use the tools.
Standard utilities, gzip, and
so the
tar.
analytics here are take the date you want, unpack the tarball, perform operations on its contents compared to some other state, job done.
Right.
Standard Unix tools approach.
Yeah, keep it simple.
So I like this because I love things that leverage the tools we all know and love, and I like simple solutions. But there is a cost here that's probably highly inefficient given the nature of the data we're dealing with, because a snapshot view of a repository, the global repository state in any point in time, includes a large amount of data that didn't change from yesterday. So there's a component of cost here that feels inescapable. You're growing a huge problem. How big was your data set when you kicked this off?
Yeah, in the early days, it was like 112 megabytes per snapshot. And already back then, people pointed out to me like, man, that is big. And why can't I download the difference? But in constructing the snapshots, constructing a differential was expensive on the server side. And it's also challenging to explain, like, how do you operate the differentials?
Yeah.
So I was like, okay, yes, I agree. It costs a little bit more.
That's a problem for later in the design hypothesis you're exploring.
And back then, disk space was cheap, right?
Yeah. So if we branch sideways, last time we spoke, you were telling us about the Erik protocol, named in memory of Erik Bice, and you kind of mentioned in passing that something you'd been exploring was idempotency in this data and ideas around canonical form and structurally canonical forms. And it interests me that we're now in a different perspective, considering archives and efficient packing and maintenance of data over a data set that you have already been thinking, what would this look like in its most canonical form, in a form I could understand and introspect over and intuit? Is this part of the process you were going through thinking about this?
I'm going to be very, very honest. The process was majorly inspired by the financial constraints I was running into. I needed it to be cheaper.
Yeah.
To give you a perspective, so in 2020, a snapshot would be 112 megabytes, and that meant I could take quite a few snapshots each and every day. And the storage requirements back then, I estimated them to be around 10 terabytes per year. And people would sometimes donate a hard disk here and there. And we built large storage arrays using ZFS and, hosting a few terabytes of data. Yeah, it's an investment, but it was doable. But if we look at the cost of storage today and how the RPKI has grown to be roughly 500-600 megabytes per snapshot with multiple nodes, right now, the original approach of RPKI views is 50, 60 terabytes per year.
That's untenable growth for what is, forgive me if I'm wrong, essentially a self-funded project.
Right. I could not run that as a hobby. And when I approach sponsors, I'm like, I need 100 terabytes per year extra.
Yeah.
A lot of sponsors are like, that's a lot, Job.
That's
that is
challenging.
A lot. So, and if I look at the size of the RPKI database, a validated cache is around 1 gigabyte. And the change rate per day is roughly 500 to 1,000 megabytes. Like out of the 500,000 objects, about 180 change. So I thought to myself, a snapshot should not be larger than a gigabyte, and the change rate is less than a gigabyte. So there must be some way to more efficiently store the data as it is discovered.
Well, my highfalutin idea that concepts that float around in Erik about canonicalization and data structure didn't motivate you, but you're actually playing in the same space, aren't you? You need to construct an interior state of the data and its change that is efficient and reproducible.
Right. So they do intersect, but the motivation was my wallet.
Yeah. So what is the intersection here?
To develop the Erik protocol, I bumped into an obstacle where I recognized in order to prove the correctness of the Erik protocol, I need a way to efficiently express the state of a derived validated cache. So I came up with an idea called CCR, Canonical Cache Representation. And the idea of CCR is that you, sort of like what you have for BGP in MRT and what you have for DNS in DNS TAP, and for just raw Ethernet frames, you have PCAP. And I thought to myself, we need a tool in the RPKI ecosystem to accurately and efficiently and performantly capture what were the inputs into the process and what was the output at a given point in time.
So this is a space that I think has been in IETF for a very, very long time. And we have things like CBOR and CDNS as approaches to constructing canonicalized states, often on the wire. They may operate in higher levels, and so decisions are made in things like CDNS. We can reconstruct the query, but we've decided not to be able to reconstruct everything about the encapsulating packets that sent it. So various decisions get made. Did you have to make a conscious decision to discard something in CCR?
No, I think I managed to make a lossless image of.
Wow.
What
encoding do you use for this canonical form?
You're going to love this. My reasoning was we use DER, distinguished encoding rules.
This
for
came
everything.
Up last time.
Yeah. So,
my least favorite protocol. So you're using the binary efficient, archaic 1960s encoding.
Absolutely.
Do you have a particular library for ASN1 that you like to use?
I use libcrypto, which is the C sort of standard interface. And there's two implementations, OpenSSL and LibreSSL. And that is usually what I work with.
Yeah, I spent some time using older libraries, and Christian Wiedemar from INRIA had access. He may well have authored a really lovely encoding library. I know that there are some highly efficient Java encoding models that people have used at places like BBN. Russ Housley, I think, maintains his own code that he uses to validate ASN1 specs he sees in passing in the internet.
For every language, for every system, there are ASN1 libraries. You can work with it in Python.
Yeah.
The NLNetLibs team did a great job
with
Job,
you're never going to make me change my mind. I hate it. But anyway, you chose it. It's your decision. You're using ASN1.
Allow me to convince you. So we have CCR, and on the input side, it has a field called the manifest state. And this is basically a list of hashes of the manifest objects that contributed towards the validated ROA payload state. That is the output.
So it sounds very similar to aspects of the Merkle tree behavior that you discussed in Erik last time. We have now taken namespace-based objects and converted them to instances of hashes that are efficient statements of change over data. So I like this so far. You convinced me last time. We're now talking an initial block of hash state.
Right. Not only it contains the hash, but also feels like the size of the object and the canonical location of the object, which is the subject information access field.
The SIA field
Yeah.
from an X509 certificate relating to this object.
Right. And it uses the SI field verbatim. So this means that in the construction of a CCR, you maintain pointers to the memory regions of the objects that you're later going to serialize to disk.
Yeah, because these names, the SIA references, become useful performing behaviors like classic validation, path building inside the cryptographic hierarchy. These are aspects that can be useful for introspecting about the data.
Right.
They're kind of important index qualities in this information space.
So in essence, the CCR contains fragments, literal fragments of the underlying manifest objects that are used to construct the input. And by using fragments, if you put this data together in, say, a tar file, you have repeating data because the fragment appeared in the manifest, of course, but now if you put the manifest and the CCR together in a tar file, the fragment is repeated in the CCR. And then if you do compression, like Z standard compression, you get insane efficiency rates because Z standard is like, well, I've seen this string of bytes
You,
before.
in effect, have given it a catalog of the strings it's going to subsequently contain and allowed it to maximize its Lempel-Ziff-like dictionary construction to say these instances are known. Here's the token that is 10 to 1, 20 to 1 shorter than the data you're going to need. So you preload the compression dictionary by pre-providing the string sets that are going to appear.
Right.
That's really smart.
Yeah, well
it
was more something I discovered as I went along because for the Erik protocol development, I needed a way to compare rsync, RDP, and Erik. And then I came up with CCR. And then later on, I bumped into this problem that RPKI fuse storage requirements were becoming too costly to sustain. And I thought to myself, what tools do I have to express the state of the cache? And I realized, we did the CCR project to support the Erik protocol development, but CCR is also a standalone tool that can be used to reconstruct points in time. And then I put the objects and the CCRs together in a tar file, and I ran the compressor, and I was just amazed by how small it had become.
So you had a size you mentioned for the size of this data if you perform the fetching from all the repositories. You've said it's around 500,000 objects.
Yeah.
And the objects are somewhere between the 2K size.
Yes.
This is building up to about 500 meg of data.
Yes.
You now perform CCR.
It goes to like a gigabyte.
So a gigabyte. You perform CCR to canonicalize this and construct something that is a efficiently encoded state. What does the size become?
So a CCR object is around 20 megabytes.
A gig to 20 meg.
But it's only references to the objects in a gigabyte, right?
So it's a cataloging state, a reduction to 20 meg from the gig. Okay.
Yeah. And if you compress a CCR, if you compress one CCR object, it compresses to around 10 megabytes. Now, if you put multiple CCRs together in a tar file and compress that tar file, guess what it compresses to? 10 megabytes.
Because
you have so much redundant data if you put the CCRs next to each other. And the change between one CCR to the next CCR, and because it's ASN1, there is a canonical form of how you express the bytes on the wire. This means there's a lot of duplicity in the data, and you end up storing only the differences between the CCRs and the RPKI.
Right. So if you were a conscious agent constructing the efficient storage model, you would in effect be recapitulating what Z standard does, constructing compression states over data with regular recurring sequences. And you're saying, why reinvent the wheel? You have to have the sequence of CCRs because you're snapshotting. The point is to detect when things change. The CCR simply encodes the hashes, and if there's no change in the hashes, the compression will elide them to the tokens.
Yep.
And then you're left with this token changed, that becomes the growth. It's functionally close to the constant size with a small amount of growth.
Yeah.
It's basically saying this 10 meg 100 times if nothing changes.
Exactly. And that means I can have many, many data gatherers around the world, which is what RPKI Views has. There's nodes that are in Bangalore, in Sydney, in Amsterdam, in Zurich, and all of them produce CCRs as they produce validation states. And they send the CCRs to a central location. The central location puts all the CCRs together in a tar file. Z-standard compresses the tar file. It sees that there's lots of duplicate data. And you end up with tar files where every day is represented by roughly a gigabyte worth of data. So now, instead of storing 3 terabytes per month, I am storing 30 gigabytes per month. And I have higher resolution. So with the previous RPKI Views model, I could instrument, say, 5,000 snapshots per month. With the new model, I can produce 40,000 snapshots per month. So this is a fantastic optimization in terms of higher precision, higher resolution. We have more data points, so we have a better insight in how exactly the RPKI state is changing as a distributed database.
And this, similar to route views, this is not a single point collection. You've just said this is the representation of visible validation states in time across quite a large distributed surface.
Right. And there's not only geographic distribution, but also distribution in terms of, say, synchronization transport. So some nodes do RRDP, and if that doesn't work, they'll fall back to rsync. Some nodes do only rsync. Some nodes reset their RRDP state, so they follow only the full snapshots. So some have IPv4 access, some also have IPv6 access.
And you are encoding this in your collection structure, so you understand these differences?
For all of them, I collect the CCRs, and then I can compare the outcomes. And I can look at, like, does one node arrive at very different states than other nodes?
Are you starting to see these variations in behavior?
Yeah, there are variations. They're small, but it's not zero. And all these variations are in what I call an RPKI spool file. So an RPKI spool is this method of put a bunch of CCRs and the raw data together in a particular structure using a particular file naming scheme and offer that as in Z-compressed form. Now, this is something I want to emphasize. RPKI Views collects raw data. We do this because I believe that future researchers may have requirements that I cannot foresee. I don't know what tomorrow's researchers will want to inspect. So by capturing the raw data, the DR-encoded certificates and manifest and ROAS and CRLs, etc., I do not put any limits on what future researchers can do with the data. And I think this is very, very important to emphasize.
Well, this is similar to the Oregon Route Views repository. This is not their statement of claim of the important bits of BGP. It's just what BGP is. And other people come to that place and use that information to construct their view. This is the interesting part I want to introspect on. So if you were a researcher or a student looking for a thesis topic and it emerges into some aspect of the RPKI ecology, what you're doing, Job, is you're providing a fundamental data source for these people to do their research in. No constraints.
Yep. And it's now affordable because on my laptop, I have a few gigs of storage available, and I can easily fit like a month worth of RPKI data in 30 gigabytes.
So there is, of course, the data processing cost. You now have incurred a runtime cost to decompress the stream, to find the differences, to construct the states you want to experiment on in data terms. Nothing is free, but in terms of the space component of cost, you've solved a problem. Do you notice a time burden processing spool files?
Yes, absolutely. And this is the engineering trade-off. In order to replicate the data in a real-time fashion, that would be very costly. But if I segmentize the data into segments of a day, so 24 hours, and I follow the UTC time zone to organize it all, and then focus on yesterday's data, deduplicate all that data, order it, sort it, mix it in with the CCRs, and then compress the resulting tarball. What the system I constructed basically gives you yesterday's data with a few hours of delay. So the nodes are collecting data throughout the day. They send it all to a centralized location. And at 6 a.m. of every day, I take yesterday's data and do the compactization process. And that takes about 2 hours. And then the result is published. So you get access to yesterday's data with roughly an 8-hour delay.
That's not bad.
It's not bad, but it's high latency replication. And that's okay because the gains are in the storage.
So if you were looking to introspect about gross properties of RPKI in the world, I feel from what you've said about this system, we can already answer primary questions. What is the rate of change? What is the rate of growth? What is the distribution of participation by discrete source node? These classes of questions you could actually track trivially as first-order measurements against the data set. If you want to say, what happens if I change the ROA for 1.1.1.1? Or I'd like to see the beaconing that I know is happening. Now you are diving into this information space, reading it to find instances of prefix and origin. That's costly. So there's a class of metastate about the health of RPKI. That's available fairly simply.
Yep.
And there's a class of in-system data. It's available, but there's a compute cost against the compression. Yep. But that's a trade-off, like you said.
Yep.
It's engineering.
And the RPKI Spool idea, my idea is that some researchers may prefer to use Parquet files. Some researchers may prefer to use Postgres or MySQL or CSV or something else.
Or even ASN1.
Or, yeah, whatever. And you take the data from RPKI views, you convert it into something that is suitable for your research, and there's no limitation because you're given the raw data. So you transform it into whatever research infrastructure you're using, and off you go.
So have you written a suite of tools to read and construct these files that people can download?
There is a little bit of tooling available. It's called RPKI Spool-CLI. Fedor Fompe from Deutsche Telekom is maintaining that tool. There is an internet draft that explains the RPKI Spool format for parties to have a stable reference. How is this data constructed? What are the naming conventions? What are the exact data formats and encodings that are used? Because this is an open data set. So I felt it is really important to document how does this system work? How can I interact with the data? What can I expect from an RPKI spool file?
And now for your own research, because you also have been interested in the dynamics of the system, this has become the fundamental underpinning. This is the data source you come to look at what's going on.
Yeah, and I have found amazing things in the RPKI spool files. With the previous RPKI views, I had trouble working with the data I produced. It was so many gigabytes of data per day that comparing it was challenging. But now that the data is in much smaller form, so let me give you an example. I discovered that under certain circumstances, the APNIC hosted CA system can reintroduce a ROA from months ago. And I've been in touch with the APNIC staff and we're debugging why this happens, but old files reappearing is a very quirky behavior. Yeah. And it warrants investigation, and it's probably a software defect.
And it's something you were able to see by looking at what was cropping up as the differencing between the states of this system.
Exactly. And another example, I discovered that there was a backdating software defect in the Aaron-hosted CA system, because sometimes ROAs would appear in yesterday's RPKI spool that were dated like months or long time ago.
Yes, there's this problem that the cryptographically assured statement, I made this on Thursday, doesn't strongly equate to file marked information in a file system. This is the date the bytes were written to disk.
Right.
And in the protocol, we make strong cryptographically validated asserts, I know when I did this, but on disk, well, that's a bit more mutable.
But it wasn't just on disk. They were backdating the validity window. So what had happened was they have a feature in their web UI where you can change an existing ROA.
Right.
And instead of reissuing a new ROA, they took data from the old ROA and the validity window and the CMS signing time copied over from the older version of the object.
So to be strictly clear, in this cryptographic model, it's not actually possible to change a signed object that occurred back then. It's a new object is made that contains parts of the bit stream that were signed over, but they were copying the bits of the bit stream that really shouldn't have been in this data.
Exactly. And with RPKI fuse data, I had evidence like, hey, your system is not fully complying with the agreed upon IETF standards. So it's really cool how this platform of open data collection is helping the participants in the ecosystem to improve their practices and find software defects and then fix them, because we now have great visibility into how the machinery is working.
Yeah, I really like this, Job. I like this quality that you can be involved in a system, designing it, arguing, defending, proposing, and separately just measuring. Here's a measurement, here's a collection exercise, here's everything that we have ever seen at the synchronization rate held in a way that I can keep doing this and scale this to meet future growth. I think that's really great, Job.
Yeah, and to give you another example, this data set, it informs the standards development process. So some time ago, work was done on a particular field of signed objects called the CMS signing time. And in the CMS, you have two ways of expressing the time. You can express the time in a certain format called generalized time, or you can express the time as a POSIX timestamp, so the seconds since January 1st, 1970. So there's two ways to encode a timestamp. And while we were revising some aspects of the signed object templates, it dawned upon me that it is actually quite unhelpful to have two ways to do the same thing.
Yeah.
And what if somebody, by accident, puts in both...
And what if they don't agree?
And both the timestamps, and what if they don't agree? So what I did was I took the RPKI fuse data and I parsed all the objects for like a really long multi-year period. And then I could make an argument to the community and I said, hey, apparently nobody ever uses the binary form of the signing time. So it is safe to deprecate the use of the binary form.
This is a great example of the value of a deep time repository like RPKI views or route views. You can make a strong assertion. I checked back. Nobody's doing it. It's never been done.
And if we would not have had RPKI views,
it would have been an open question.
Right.
What if somebody is doing this? This is risky. No change.
Yeah. And the effect would have been, we cannot change the standard because we lack the information to make an informed decision on.
Yeah, I think you're right. This kind of facility is what makes it possible to advance the technology we're depending on. Job, that's been absolutely fascinating.
And let me share one more fun fact. I took a look at ROA creation times, and then I mapped that to days of the month, and I discovered something funny. People don't like changing ROAs on the weekends. In the RPKI fuse data, you can very clearly see that there is a different churn on business days versus Saturdays and Sundays. So yeah, there's incredible insights to be derived from this data. Like, when do companies make changes?
We should inform the operators union that they are not required to work BGP on weekends.
Yeah, exactly. And, this extends, of course, to understanding what are the change windows freezes around holidays.
When is it safe to perform? It has aspects of that societal, social component of how complex system works.
Human behavior is bleeding through into this data, and we can now try and analyze it.
Yeah, that's a good one, Job.
So call out to the community.
Yeah.
RPKI Spools is a format you can use if you're a researcher. I'd be happy to help you if you have questions about the format. So please reach out to me if you have an RPKI related project and the project needs data, because maybe I can help you set up your analytics pipelines, or maybe your use case can help inform how we better describe what the system looks like. So researchers, take this as an open invite. RPKI data is available at a huge discount. It's available for free. It's only 1 gigabyte per day. So yeah, I hope to be collaborating with people and in that way do cool things with RPKI views.
That's great. Thank you, Job. We'll talk to you again.
Thanks, George.
If you've got a story or research to share here on Ping, why not get in contact by email to ping@apnic.net or via the APNIC social media channels. Also, remember, the Measurement at apnic.net mailing list on Orbit is there to discuss and share relevant collaborative opportunities, grants and funding opportunities, jobs and graduate placings, or to seek feedback from the community on your own measurement projects. Be sure to check out the APNIC website for all your resource and community needs. Until next time,